All right, now on to synthesis and decomposition. So synthesis by definition means to make. Decomposition means to break apart, right? To decompose. So what we're going to do now is we're going to go through some examples of some synthesis and decompositions. So the first thing we need to realize when we do synthesis and decompositions is what they actually do. So what ends up happening with something that's a synthesis is if we had a substance, let's just call it substance A, right? And it reacts with substance B. In a synthesis reaction, what would occur now is a compound would be formed, A, B. Meaning we would take the two things and put them together, right? Now, decomposition is the exact opposite. You have now that substance, A, B, okay, it's a compound, and that compound breaks down into its individual pieces, A plus B. Alright, so hopefully that kind of makes a little bit of sense here for us. Synthesis, decomposition. Synthesis, we put them together. Decomposition, we break them apart. Now, there are some rules that govern this. And so what I'm going to do is I'm going to take you on a little journey. I'm going to turn you around. And in your packet, you're going to see these rules right here. There are 5 of them, okay? Direct union of elements will produce a binary compound. I'm going to try to keep this as steady as possible. You can see below an example here of number 1. Then, metallic oxides and carbon dioxide produce carbonates. 3, rule 3, is binary salts and oxygens produce a chlorate. Number 4, metallic oxides and non-metallic oxides make an acid. Okay? We're going to do a bunch of examples in class. But I want you to also look at the rules that have to do with decomposition. Well, look at that. Binary compounds break down into their individual elements. Carbonates break down into oxides and carbon dioxide. I don't know why that's spelled wrong. Apologize for that. Chlorates break down to a binary salt with chlorine and oxygen. Bases break down into oxides of metal and water. And 5 acids break down to oxides of metal plus non-metal, or plus water. Oxides of the non-metal plus water. So again, here are examples 1 through 5 of those types of reactions. Now the reason I say that is if you look at these 2 pages, you would note that they are the exact same rules in opposition of one another. Now what I'd like to do is do some examples. Alrighty, so with synthesis, what I've done here is I've put the first 5, alright, the skeleton, the first half of them on the board, okay? And so what we're going to do is we're going to go through these, we're going to tell you what rule we use, and go from there. So each of these right now is a synthesis reaction, okay? Every single one of them. We're going to take 2 things, we're going to put them together. So, the first one here, this is a rule number 1, okay? And what ends up happening here is the magnesium ends up being synthesized together with the oxygen. So what we end up doing is we take magnesium, Mg, and O when we put them together, okay? Magnesium has a +2 charge, oxygen has a -2 charge, so I've written it right as MgO. You do have to do that part, you have to make sure. I can get rid of the charges just to clean it up, MgO, and now I got to also balance. This one does not balance, so what you end up doing is putting a 2 there, that gives you 2 O's and 2 Mg's, right? Well, if you put a 2 right there, you get 2 Mg's, and now you have a balanced chemical equation. Yes, you must balance it. This one is also a rule number 1. It's 2 things, we put them together. So again, we take silver and oxygen and put them together. Oxygen is -2, silver is on your ion sheet, it's +1. Therefore, it's going to take 2 silver plus 1s, right, to cancel out the -2 of the oxygen. So we get rid of the charges just to keep it clean. And we need a balance. On this one, I tried 2 right here. That gives me 2 times 2 for 4 silvers. So I got to put a 4 right there. And that gives me 2 times 1 oxygens, 2 oxygens. It's balanced. Which brings us to number 3. Number 3 is a non-metal oxide. Phosphorus is a non-metal. Non-metal oxides and water, according to rule number 5 make acids. Now I kind of help you. I tell you that this acid, you need to name it an OUS acid. So what ends up happening is this. Acids always have an H at the front. Always. And what's going to be made from the acid is it's going to be something with P's and something with O's. Why? Because there's phosphorus and there's oxygens involved here. Now we got to ask ourselves, okay, well, should this be, HPO4, HPO3, etc., etc.? Well, this OUS part helps you. We know that things that are phosphite becomes phosphorus acid, right? And that's why the OUS is there. So this is HPO4, or PO3, and that makes that a -3 charge. This is +1, right? Therefore, I need 3 hydrogens plus 1, plus 1, plus 1 to be able to cancel our charges. Again, I get rid of those charges just to clean it up. H3PO3. Last thing you have to do is you have to balance it. So this is 1, 3, and 2. Yeah, I'm cheating because I want to be able to go faster. All right, here. Metal, oxide, and water. Well, metal, oxides, and water, according to rule number 4, make bases. So a base is something that ends OH, hydroxide, and it carries a -1 charge. Well, that accounts for the oxygens and the hydrogens, right? Leaving us K. So this is KOH plus 1. So it is KOH. That is the proper way to write it. However, this does not balance. So then you end up looking at the balance and you say, I think it's a 2, yeah. You end up putting a 2 right there. It gives you 2 potassiums, 2 oxygens, 2 hydrogens. That's cool because 2 potassiums, 1 plus 1 is 2 oxygens and 2 hydrogens. Number 5, okay, what number 5 is number 5 is a rule number 2. Rule number 2 says that when you have a metal, oxide, and carbon dioxide, you make a carbonate, right? So something that has CO3 with a -2 charge in it. That's what a carbonate is by definition. Well, that accounts for the oxygens, accounts for the carbon, but doesn't for the barium, right? Well, that's okay, because this is a synthesis. We're going to take everything, we put it all together, so we make barium carbonate. Now, the charge on barium is +2. So, +2 minus 2, they cancel each other out. I get rid of those charges just to keep things clean. Ba1. 1 plus another 2 is 3 oxygens. C, it balances. Alright, there's one more on the synthesis side I want to do for you. So, first of all, let's go through the rest of them. Number 6, right? Number 6 is just a rule number 2. You can handle that one. We've already done an example. Number 7 is a rule number 4. We've already done one also. Rule number 8. Or I mean, number 8. Number 8 is a rule number 5, I believe. Yep. So it's a rule number 5. And remember, the acid here is going to end ic, meaning something comes from an 8. But number 9 is brand new. We haven't covered this rule yet, so I do want to do number 9 with you. Number 9 says this. We have NaCl. This is a salt. A metal in chlorine is called a salt. That's why we call it salt when we go to, McDonald's or wherever you go to eat. So salts plus oxygen, right, O2, make chlorates. Now, this rule is referred to as rule number 3. And again, it's number 3 says a salt and oxygen makes a chlorate. Chlorate, by definition, is ClO3. It carries a -1 charge. Sodium is the part that's left, right? You counted for your chlorines, you counted for the oxygens. We'll talk about the 2 and the 3 in a second when we balance it. So the thing that needs to be put with this is the metal, which is the sodium. Sodium is +1, so yeah, you're good to go. Okay? Get rid of your charges just to keep it clean. Now, what I do here is I look at, okay, what do I need in order to balance this? Well, if I try a 2 right here, that gives me 2 sodiums, 2 chlorines, and 6 oxygens. Well, that's okay, because I can put a 2 right there and a 3 right there. Number 10 is also a rule number 3. Now, let's talk about decompositions. You know what I'm going to do on these? I want you to do them because the rules are exactly the opposite. But what I'm going to do is I am going to take you through the decompositions and at least say, okay, number 1 is this rule. Number 2 is this rule, etc., etc., etc. So number 1 on the decomposition now problems. So we are now to decomposition, the next page. Okay, so this is page, I think it's page 14. So page 14. Number 1, this is a rule number, so I gotta look at the problem, make sure. This is, so we have a chlorate. Chlorates break down into salts and oxygen, we just said it. And so again, that is rule number 3. It's the exact opposite of rule number 3 on the other page, on the previous page. Alright, number 2, you have silver oxide. So what you end up having here is you end up having 2 things breaking apart. This is a rule number 1. Number 3. Number 3, HNO2, what that is something called nitrous acid. Well, when we look at our things and look at what rules govern acid, it's rule number 5. Number 4, okay, number 4, what you should have for number 4, let's see. Oh, there we go. It is ferric hydroxide. Hydroxide is a type of base. Therefore, this one is a rule number 4. And number 5, this is a, let's see, number 5 says, oh, it's a carbonate, zinc carbonate. So I look at what rule governs carbonate, that is rule number 2. So you should now be able to go through it. The one thing you need to remember is you need to balance, balance, balance. Now, now what I want you to do right now is I want you to go through and do these different problems, and then I want you to hit pause right now, because in a second what I'll do is I'll show you the answers. Now, if you don't get a chance to do that, or if you're not honest, then you won't be able to do the work, and hopefully, or not hopefully, but you're not going to be able to do the problems when I ask you to do them. So, here we go. So here is 1, 2, 3, 4, and 5. Again, rule 3, rule 1, rule 5, rule 4, rule 2. Alright, you should be able to do 6 through 10 on your own. Again, I think that there is, on this one, there is a rule 2, a rule 4, a rule 5, a rule 3, and a rule 1.